Hello, my name is Kathleen Amandano. I'm in Dr. Navard's AP Calculus AB class during mods 4 to 6, and I have chosen to do the arc length project. So to begin, the path I chose was a path in Johnson Park parking lot in Hackensack, New Jersey. This path is very trendy with those who just have begun to learn rollerblading. They would start at this point by a tree, and they will try to go in a straight line to the end point of the parking lot. Then they would basically try to go over or around the first pole, then under and around the second pole, and all the way up to a corner of the parking lot. Then they would just come back to the beginning and start again. And in order to find the path length, I decided to put this path into a I decided to plot this on a graph using different coordinate points, and I did so by using a measuring tool found on the website that this path is located on in order to measure from this point to this point to find my y output, and I use this as my origin, so this would be considered my x input. Then I once again used this same method to measure from this point to my next point about here, and this will be used as my x input. Then once again I measured from this section to this point here, and this will be my y output, and I did this for my following 5 coordinates, as you can see here. And I plugged this into my Excel program, and it generated a graph for me and an equation for this polynomial, which can be found here or at the top right corner of my graph, as you can see. I then proceeded with finding the derivative of the equation, and you can see my steps I took here. I used the power rule in this step, and I basically took the exponent of the x, multiplied it by the coefficient in front of the x, then subtracted 1 from this exponent, and for this case it would be 3, and I did that for the following terms. To continue, after finding the derivative of the equation, I simply plug this into the equation for the arc length formula into the f derivative of x section of this, as you can see here. And for my a and b values, I inserted 0 as my a value since it is my lowest x input, and I plugged in 270 as my b value since it is my highest x input. I plugged this into my graphing calculator and got an answer about 420.57 feet. In order to double check the accuracy of my equation, I simply double checked by using once again the measuring tool found on this application, and I did my best to measure the path of these curves, and I got about 386 feet. So my equation gave me a total of 420.57 feet for this path, and it's not too great of a difference, but there is a difference. It is about a 34 feet difference. If perhaps I had used more points during my project, I would have most likely gotten a more accurate depiction of my real length of this path. But overall, the arc length function formula did work after all, and that is all for my arc length project. Thank you.